Chapter 2, the Anterolateral or Spinothalamic System, the pathway for pain, temperature, and crude touch. If the dorsal columns were the discriminative senses, these are the protective senses, the ones that warn you. And our organizing question has a new answer here. This system crosses low in the cord within one or two segments of where it enters. Watch for three landmarks as we go: Lissauer's tract, the anterior white commissure, and the crossing delay they produce. 4 objectives for this chapter. First, trace the anterolateral pathway from the dorsal root ganglion into the dorsal horn, across the anterior white commissure, and up the contralateral cord to VPL, the cortex, and the insula. Second, explain the crossing delay. Why fibers ascend 1 to 2 segments in Lissauer's tract before they synapse and cross, so that the deficit begins below the lesion. Third, separate the divisions: lateral spinothalamic for pain and temperature, anterior spinothalamic for crude touch, plus the spino-reticular and spino-mesencephalic branches. And fourth, the payoff: predict dissociated loss. Understand why central cord and anterolateral lesions knock out pain and temperature while sparing the dorsal column modalities entirely. Here's the anterolateral system on one screen. On the left, what it carries: pain, both the sharp, fast pain of A delta fibers and the dull, burning pain of C fibers, plus temperature, warm and cold, and crude, non-discriminative touch and pressure. It also carries itch, tickle, and sexual sensation, all on those small, slow fibers. On the right, the three-neuron chain, notice how it differs from the dorsal columns. The first-order neuron enters through the lateral division of the dorsal root and ascends or descends 1 to 2 segments in Lissauer's tract. The second-order neuron is the key difference. It sits in the dorsal horn, and it crosses almost immediately in the anterior white commissure, then ascends in the contralateral anterolateral column. The third-order neuron projects from VPL to S1, and, importantly, collaterals reach the insula and cingulate, which give pain its unpleasant emotional dimension. The board anchor. This system crosses at the level of entry, give or take 1 or 2 segments. So a cord lesion produces contralateral pain and temperature loss, beginning 1 to 2 segments below the lesion. This is the anterolateral pathway drawn out in full. Trace it with me from bottom to top. Start at the peripheral receptor. A nociceptor, thermoreceptor, or crude touch receptor is activated. Its first-order fiber enters the dorsal horn and synapses right there in the substantia gelatinosa and nucleus proprius. No long ipsilateral climb like the dorsal columns. Now the defining move. Follow the second-order axon as it crosses the midline in the anterior white commissure and gathers in the contralateral anterolateral funiculus. Compare that to the dorsal column figure. There, the first-order neuron rode all the way to the medulla before crossing. Here, we cross almost at the door. From the anterolateral funiculus, the tract ascends through the brainstem to VPL of the thalamus, and the third-order neuron projects to primary somatosensory cortex. Hold the contrast that this figure sets up. Because the anterolateral system crosses low, and the dorsal columns cross high, a single cord lesion hits them on opposite sides: pain and temperature contralaterally, fine touch and proprioception ipsilaterally. That opposite sides pattern is the dissociation we'll exploit all through the clinical chapter. Now we zoom in on the entry because a small anatomical detour here has a real clinical consequence. Frame 1. The first-order neuron enters through the lateral division of the dorsal root, and before it synapses, it takes a detour. Follow the fibers into Lissauer's tract, the dorsolateral tract, where they ascend or descend 1 to 2 segments. Only then do they turn into the dorsal horn to synapse. Look at the magnified inset on the right. Fibers spreading up and down 1 to 2 levels before they terminate. That vertical spread is the origin of the crossing delay. It's the reason a spinothalamic sensory level sits a segment or two below the actual lesion, and it's why we say the anterolateral deficit begins below the lesion rather than exactly at it. Fix that now. It saves you from mislocalizing a cord level by a segment. Next, we look at exactly where in the dorsal horn these fibers land. Frame 2 takes us inside the dorsal horn to the lamina where the first synapse actually happens. 3 to know. Lamina 1, the marginal zone, receives sharp A delta and C fiber nociceptive and thermal input. Lamina 2, the substantia gelatinosa, circle this one, is the modulation floor. It's dense with inhibitory interneurons and endogenous opioids, and it's where the gate control we'll cover shortly operates. And lamina 5, the nucleus proprius, holds wide dynamic range neurons that receive convergent input from skin and viscera. That convergence is the anatomical basis for referred pain, why a heart attack is felt in the arm and jaw. So the takeaway for this frame? Pain doesn't just pass through the dorsal horn, it is processed and gated here in lamina 1, 2, and 5 before a single impulse ascends. Keep lamina 2 in view because the very next modulation slide lives there. Let's pull all the way back to the full gray matter map, the lamina of Rexed, so the pain lamina sit in context. Rexed divided the gray matter into 10 layers by function. Lamina 1 through 6 are the sensory dorsal horn where we've been working. Lamina 7 is the intermediate zone, and note it now because it houses Clark's nucleus and the autonomic intermediolateral column, both of which return in later chapters. Lamina 8 and 9 are the motor ventral horn, home of the alpha motor neurons, and lamina 10 rings the central canal. The purpose of this frame is orientation, not memorization. Our anterolateral story lives in lamina 1, 2, and 5 at the top of this map. The dorsal column fibers pass nearby, and you'll meet lamina 7 again as Clark's nucleus in the spinocerebellar chapter. One cross-section, one numbering system, every tract to come. This is the crossing that defines the anterolateral system, and it's worth slowing down for because it explains 2 of the highest yield findings in the whole cord. On the last slides, the first order neuron entered and synapsed in the dorsal horn. Now watch the second order neuron in blue leave the dorsal horn and sweep toward the midline. Follow it. It crosses anterior to the central canal, through the anterior white commissure, that's the star, and then, in red, turns upward on the opposite side, ascending in the contralateral anterolateral funiculus as the Spinothalamic Tract. From there, it climbs through the brainstem to VPL of the thalamus and on to S1. Contrast that with the dorsal columns, which rode all the way to the medulla before crossing. Here we cross almost at the door, within a segment or two of entry. And that gives the 2 clinical payoffs in the boxes at the bottom. First, the crossing delay. Because fibers ascend 1 to 2 segments in Lissauer's tract before they cross, the sensory level sits below the lesion, the detail that keeps you from mislocalizing by a segment. Second, the classic. Interrupt those crossing fibers in the center of the cord, a syrinx, and you get a bilateral, cape-like, dissociated loss of pain and temperature, with the dorsal columns untouched. That cape is the anterior white commissure being cut right where you're looking. The anterolateral system isn't a single wire, it's a family of parallel pathways, and separating them explains a lot of clinical behavior. On the left, the classic divisions. The lateral spinothalamic tract carries pain and temperature. The anterior spinothalamic tract carries crude touch and pressure. And here's a clinical note worth holding. Crude touch is carried by both this system and the dorsal columns, so an isolated anterolateral lesion rarely abolishes touch. The dorsal columns compensate. That's why touch is the unreliable modality for localization, and pain and temperature are the reliable ones. On the right, the pathways that go beyond the thalamus and give pain its other dimensions. The spino-reticular tract feeds the reticular formation and the arousal system. This is what wakes you and holds your attention on pain. The spino-mesencephalic tract runs to the periaqueductal gray and engages descending analgesia, the brain's own brake on pain, which sets up the next slide. So think of it as two streams, a fast, sharp, precisely localized stream to the cortex and a slow, aching, emotional, arousing stream to the brainstem and limbic system. Pain is not a fixed readout of injury. It is actively gated in the cord and modulated from the brainstem. Two systems here, both high yield and both mechanistic, so reason them rather than memorize them. First, gate control, Melzack and Wall. Large A-beta touch fibers, the same ones that serve the dorsal columns, send collaterals that excite inhibitory interneurons in lamina 2, and those interneurons dampen the nociceptive signal before it ascends. In plain terms, touch closes the gate on pain. That's the physiology behind why rubbing a banged elbow genuinely helps, and it's why a TNS unit works. Second, descending analgesia, a top-down brake. The periaqueductal gray in the midbrain drives the rostral ventromedial medulla and the raphe nuclei, which send serotonin and norepinephrine down to the dorsal horn to suppress those second-order neurons. Opioids, enkephalin and beta-endorphin, are the currency at both ends of this loop, which is exactly why morphine works and why your own endorphins blunt pain under stress. And notice the loop closes on itself. The spino-mesencephalic tract we just met feeds the periaqueductal gray, so the pain signal recruits its own inhibition. The clinical link is real. Stress-induced and placebo analgesia are this system firing. The spinothalamic tract is layered inside the cord, and that lamination has a famous clinical consequence, so let's read it carefully. On the left, how the tract is arranged. The sacral fibers ride most laterally. They were added last and pushed outward, while the cervical fibers sit most medially. The mnemonic is SLCM, sacral lateral, cervical medial. Now on the right, why it matters. A lesion from outside the cord, an extramedullary lesion, like a compressing tumor, presses inward from the surface, so it hits the lateral sacral fibers first. Sacral sensation is lost early. A lesion from inside the cord, an intramedullary lesion, like a syrinx expanding outward, spreads from the center, so it reaches the sacral fibers last. Sacral sensation is spared. That preserved sacral sensation is the finding we call sacral sparing. So here is the exam trap, and it's a favorite: sacral sparing points to an intramedullary lesion. An extramedullary compressive lesion tends to take out the sacral dermatomes early. That single observation can tell you whether a cord lesion is growing from inside or squeezing from outside. Now we take the anterolateral system to the bedside. This is where its signature pattern earns its keep. On the left, 3 patterns of loss you should recognize on sight. A cord hemisection, Brown-Séquard, gives contralateral pain and temperature loss beginning 1 to 2 segments below the lesion. A central cord lesion, or a syrinx, interrupts the crossing fibers in the anterior white commissure and produces a bilateral, segmental, cape-like loss of pain and temperature, with the dorsal column spared. And an anterior spinal artery infarct takes out the anterior 2/3 of the cord, giving bilateral pain and temperature loss plus motor loss again with the dorsal column spared. On the right, how you test it, pinprick for sharp versus dull, and a cold tuning fork or test tube for temperature. And here's the move that clinches it. Compare. If pain and temperature are gone, but vibration and position sense are intact, you have dissociated sensory loss. That's the high yield point, so let me state it plainly. Dissociated loss, pain and temperature gone while vibration and proprioception are preserved, is the anterolateral system's fingerprint, and it localizes the problem to the cord. When you see it, you're reading spinothalamic anatomy directly off the patient. Here's the head-to-head, dorsal columns versus anterolateral on one grid, and it's a screenshot slide. I won't read every row. Pause and let the contrast set. The two systems carry different modalities, fine touch, vibration, and proprioception on one side, pain, temperature, and crude touch on the other. But the row that does the clinical work is where they cross. The dorsal columns cross high in the caudal medulla after a long ipsilateral ascent, so a cord lesion gives ipsilateral signs. The anterolateral system crosses low in the anterior white commissure within 1 to 2 segments of entry, so a cord lesion gives contralateral signs. Same modalities, opposite crossing rules, opposite sides of loss. If you hold only one idea from this chapter, hold that, because it's what turns a confusing sensory exam into a precise localization. Next chapter, we leave conscious sensation entirely for the unconscious proprioception of the spinocerebellar tracts.
Now let's demonstrate the actual deep tendon reflex examination on